All right, let's do a doubling problem. So, not much calculus, actually zero calculus here. Let's just refresh our brain so we kind of understand what it's asking and how to do it. So we're starting with an initial amount. Let's call that A naught. And we're told that every 15 minutes our initial amount or our amount doubles. Okay? So after 1 hour, how much is left? Well, let's draw a table of time versus amountage. Word I just made up. So at time 0, how much do we have? 20. After 15 minutes, how much do I have? 40. After 30 minutes, how much do I have? 80. After 45 minutes, how much do I have? 160. After 60 minutes, how much do I have? 320. So in each of these steps, I was multiplying by 2. Okay, I went up to 60 because we're asking about 1 hour. So after 1 hour, there's 320 bacteria. Cool. All right. How many bacteria are there after T hours? Okay, so this was a 1 if we're talking about hours. But now, how many times did we double in 1 hour? 4 times. Okay, so our half-life is 15 minutes, but it's asking about how much is after T hours. That means we have 4 half-lives. Half-lives. Okay, so the amount equation for doubling is initial times 2 to, I'm going to write K times T. K is number of half-lives that occur given the unit of time you're in. So it's like the conversion number. So like our half-life was given to us in 15 minutes, but I need hours. How many times does 15 occur in 1 hour? 4. So that's what that K value is. So that means the amount after a given time is going to be 20 times 2 raised to the 4 times T. So let's double check to make sure this makes sense. We said A of 1, given that T is in hours, we had 320 bacteria. So if I plug 1 into this equation, I should get 320. Let's see. That will give me 20 times 2 to the 4 times 1. So that's 20 times 2 times 2 times 2 times 2. Didn't we already do that? We did. So that does equal 320. So that's how you can kind of check to see how you did it. The most common mistake is forgetting the 4. So make sure you don't forget it. So K is greater than 1 if your half-life, so like if it's like minutes to hours, your half-life will be greater to 1. But if it was like hours to minutes, then your K value will be less than 1. Like you might have to do a half or something like that. Like for example, if your half-life was 2 hours and we want the equation for T hours, well, what's our K value going to be? 1/2. Does that make sense? Okay, hopefully it does. All right, moving on. Estimate the number of bacteria after 25 minutes. All right, let's use the equation we just wrote in part B. But now remember, A of T in this case is in hours. So if I plug 25 right into here, that's going to give me the amount after 25 hours. I don't want the amount after 25 hours. So we need to convert 25 minutes into hours. How do we do that? Well, how many minutes are in an hour? 60. So this will give me my hours. So now I can plug that in. So really I want the amount after 25 over 60. So I just plug that right in. Notice how it says, set up the equation. We have set up the equation. I.e., I could plug this into a calculator if I wanted to, but I don't want to, and you won't have one. So, there you go.